Welcome to the first devlog for a VR game our team and I are calling Mirade. At the moment, there's not much to show off, but hopefully as this series continues, and as I improve as a programmer, this VR game will eventually become something really unique. Without giving away too much, the current end goal for our team is to have a VR survival game with in-depth combat mechanics and AI. The game will take place with the player stepping into the role of a tribe member within the species known mainly as the 𝗏. The game takes place in the Mesolithic era, when people were refining their use of stone tools and discovering the benefits of agriculture. There will be a story to go along with all of this, but it would be best to keep that part of the game under wraps until we've developed a more concrete version of what we want it to be. If you'd like to know more about this kind of stuff, there will be a link in the description to our website with much more detail on what exactly we're going to be doing in both the long term and short term. If you've read the title of the video, you've probably realized that today is going to center around the development and experimentation of Mirade's cartoon shading and aesthetic. It's very important to the team and I that we develop shaders that allow for heavy customization of style, material, environment, and so forth. The biggest roadblock, however, is at the beginning of this journey, I had no idea how to write shaders at all. So this will also partially be my adventure in learning the magical hair loss program, also known as Unity's Shader Lab. Getting right to the point, the first couple of days consisted mainly of researching how writing shaders in Unity's Shader Lab actually worked. Using two programs called GLSL and HLSL, you could tell the computer how it should render pixels on the screen. After looking into some tutorials on the matter, I decided that I would primarily use GLSL to program the shader in. This would eventually turn out to be possibly the worst decision I had ever made in my entire life, second only to deciding that writing my own shader was a good idea in the first place. After reading some GLSL documentation and following a few tutorials, I embarked on my magical shading journey, starting with learning how to render objects onto the screen, even if it was just a single color. After my triumphant victory in that department, and after a bit more struggle than I'd like to admit, I was able to project this handsome gentleman onto the sphere as a texture. Now, while a textured sphere is already a technical marvel on its own and deserves a Nobel Prize, I feel that the shader would probably benefit a little if it took lighting into consideration. So, after my perilous journey of stealing someone else's idea, I implemented a function that would calculate the position of Unity's main light source relative to the given pixel, and then change its brightness accordingly. Combining that function with a little bit of math, I was able to achieve the blocky lighting effect that is commonplace in cartoon-like shading. At this point, I was feeling very confident in myself as a programmer, and swiftly moved on to the next step of the shader and started experimenting with how I could implement Unity's additional light sources. For those unaware, shaders in Unity handle both the main light and additional lights in separate ways, so calculating them requires separate code. Unbeknownst to me, GLSL had been deprecated by the Unity devs quite a while ago, and the new rendering engine that I was using for the project had not been developed in a way that would easily allow the calculation of additional lights. Thus began the months-long journey of not knowing why my code could not at all correctly calculate lighting, and me slowly losing my mind over it. Eventually, I found out about GLSL being deprecated, and shamefully dumped my code in favor of writing it all again in HLSL. Having spent the last few weeks learning how to write shaders in GLSL, it took me a bit of getting used to switching over to the new shader language. Eventually, however, I was able to once again calculate the main light source, and after a lot of brainpower, I was also able to finally calculate the additional lights as well by having a loop that went over every light source affecting a pixel and combining those lights together. Afterwards, I spent some time tweaking everything to ensure that it both looked acceptable for our game's alpha, as well as ensuring that the shader had some form of very basic customization options to aid with the development of our alpha tests of the game. Considering that only a few months ago I had no idea how to write shaders at all, I personally believe that this was a huge success, even if it did turn me into an emotionless, unfeeling husk of a person. After spending so much time on this project, I decided to model a very simple scene to test out how this game might look like in its early alpha stages with this new shader applied. Using my less than adequate Blender skills and my incredible skills of downloading 3D models off the internet as a placeholder, I quickly created a couple of 3D objects that I was able to export into Unity without much problem. After setting up a new scene and applying the newly completed shader where necessary, all that needed to be done now was put on the headset and see how it looks. Thank you all for watching until the end of the video. If it's of any interest to any of you, I would love to be able to create a tutorial for the shader so that you can avoid the struggles that I went through while developing it. This took quite a long time to put together, so any feedback and criticism would be much appreciated. If you're interested, feel free to join our Discord in the description below. Once again, I thank you all for watching, and I hope you all have a wonderful rest of your day.